Hello everyone! Welcome to Analog Patch, it's Astro. The weather is amazing today. So beautiful and sunny outside. Yet I am here programming my music computer. And this is the second part of the vlog about it, dedicated to these 4 digital to analog converters that I'm currently making. It's part 1 out of I don't know how many, because they don't still work. Only one of them functions seemingly properly, but still I am there to show off. So basically, these are 8 bit shift register, and each of them has a dedicated R to R ladder. So those ladders, they are used to convert 8 parallel bit lines, analog voltages, which are only 0 to 5 volts, so either 0 or 5 volts, to a more contiguous staircase-like voltage. So basically I have a resolution of 8 bits, and I can output any value between 0 to 5 volts, but only out of 256 values that I have. Anyways, enough nerdery. So I built 4 of these, one of them works. I could have used PWM built-in options of Arduino, and people use that, I know that, but I wanted something more solid. Plus I'm going to use one of them as well as a gate generator. So these are mainly used for CV, no audio, but this one will also be used as a gate output. So this option is kind of more solid to me, looks better. Plus, you know, who goes the easy way? You know, this is more fun. Anyways, this demonstration here is just to demonstrate that it's working. It will not be used this way mainly, although I'm planning to use it this way as well. Still, so what I have here in my Arduino code is very simple stuff. So basically first I initialize A as 1, and then in the loop, which is the piece of code which will be looping over and over in Arduino. Oh, my face is visible. Anyways, what I do is, let's comment this out first. So first I'll show you a simple sawtooth. Oh, what's happening? Let's comment it like this. So it's very simple. We have A equals 1, and then each step we multiply it by 2. And if it's 256, which we will not be able to fit into 8 bits, then set it back to 1. So it will each step go 1, 2, 4, 8, 16, 32, 64, 128, and then back to 1. And we put this to all of our DACs through the strobe data function. It's a function that I made. It's really silly. It's really inefficient. Of course I will remake it, but for testing purposes it will do. Anyways, so the values which we're getting are exponentially rising. So like 1, 2, 4, 8, 16, 32, and so on. So what we'll get is a cycle of exponential rises, supposedly sounding like a sawtooth. So let's see. Let's try it. There is our box. Oh, let's click the upload button. Hear what happens. Oh, look, it's not bad at all. It's a literal sawtooth. And now let's introduce a little delay between the cycles by uncommenting this. Boop. Let's load it up. And it's lower. It also changes in timbre a little bit because the delay is introducing just a gap between those cycles. It doesn't make the cycle itself slower, but still, if we increase the delay, it of course will make things even lower in pitch. So I will unplug this for a while. So yeah, let's change things up a bit, just to have fun. So comment this delay. Let's comment this section. And instead of doing that exponential sawtooth-like thingy, we will just put a random value. into A each cycle. So just get a random value between 0 and 255 and put it to our digital to analog converter. And we will get something along the lines of Game Boy type white noise, although it's not generated with a linear feedback shift register. It's generated with some other routine, so it sounds a little more white noise-ish. But anyways, let's see. Let's plug it back in. Let's upload. And there we have it. Very Game Boyish white noise. Let's make it slower. So introducing a 1 millisecond delay. And it indeed became slower, more low-pitched. And in case of white noise mode, so to say, it will actually become slower because it will just slow down the whole cycle. Anyways, so it's kind of working, it's kind of fine, but it's just one of the 4, so I have to fix the other 3 DACs and actually check if they're doing their thing, because maybe they are not actually outputting what I'm expecting. So after all of this, I will proceed to completing at least one of my ideas with this, of connecting a keyboard to this box, which I've done in the previous vlog, to this input port, and assigning a voltage to each key, because each key has a character, one byte long character. So just put whatever the key character byte is to the DAC and let that be a kind of a very strange keyboard, and then test it out on my synthesizer. So yeah, those are the plans for the future, but for now I have one entire whole working 8 bits of glorious resolution. Thank you for watching. I hope you had fun. I hope you got inspired to do something, or at least I hope, I don't know, you liked my figures and the sun outside. It's cool. Anyways, catch you people later. Goodbye.